Good morning. As you can see, placement's finally set up. Back to the regular recordings posted. Should have watched the recording on polynomial functions. Not that big of a deal. Nothing too difficult, so we didn't really miss much. This is the big one. This one and our next meeting will be the two big ones. Probably also the hardest thing we do all semester will be on Wednesday. Today we look at dividing polynomials. Start with a recap of the division algorithm. So this is for any any integers. I guarantee you're familiar with it, even though you may not be familiar with the name and the terminology. So what the division algorithm says, every pair of integers, m and d, you have a unique pair of integers q and r, where n is d times q plus r, and r is between 0 and d. M is your dividend. D is your divisor. Q is your quotient. R is your remainder. All right, that terminology should definitely be familiar. And the technique that was taught when you're first dividing numbers. Long division. Does that sound familiar? It should. Saw a lot of people write about it on the first discussion. Well, let's extend this to polynomials. The division algorithm for polynomials. And if you keep this slide in mind, you should see a lot of parallels. Given any polynomials, f of x and d of x, there exists unique polynomials q of x and r of x, such that f of x is d of x times q of x plus r of x, where the degree of r is between 0 and the degree of d. A degree 0 polynomial is just a constant. Your f of x is called the dividend. Your d of x is called the divisor. Q of x is your quotient. R of x is your remainder. two methods for dividing polynomials. First one is all too familiar. Polynomial long division is what it's called. So it's just an extension of the long division that you learned in primary school. Works pretty much the same way. There is a simpler method. However, it can only be used under special circumstances. So this second method is called synthetic division. And it can only be used in the case where your divisor is of the form x minus k, where k is some real number. With some slight adjustments, you can use synthetic division if the leading coefficient of your divisor is not 1. Right, so it's like 3x minus k. With some tweaks, you can still use synthetic. However, it's probably simpler just to use long division until you get the hang of it. Unlike in long division, in synthetic division, we only care about the coefficients. So whenever it is possible, we will be using synthetic division. So obviously we're going to have a mixture of synthetic and long division. Looks like there's only 2 problems that actually require long division. The rest can be used with synthetic. Find q of x and r of x for this pair of polynomials.
So you want us to use synthetic division first?
Right. Typically, we look at the divisor and we go, is it of proper form? It's not. Now again, I could tweak that just a little bit. Right, and the reason it's not proper form is because of that 2 in front of the x.
And even if you had like x plus 3, for example, you could still make
We do have a case like that, yeah. So we'll see what happens. Polynomial long division. Again, it works pretty much the exact same way as regular long division. Outside is your divisor, inside is the dividend. And now here's the game that we play. Look at the leading term of the dividend. What is it? What is the leading term of the divisor?
2x.
So what do you have to multiply 2x by to get 2x cubed?
X squared.
Now perform the multiplication. And you subtract.
So in this case, it would be 6x squared.
2x cubed minus 2x cubed is 0. 3x squared minus negative 3x squared is 6x squared. And
Minus.
we don't typically write it, right? But understand that those are implied zeros. So in a sense, the remaining terms just carry down because you're just adding a 0 to it. Now look at your new dividend. You want to check the degrees. What is the degree of that new dividend? Degree of the new dividend.
The 2?
It's 2.
Yeah.
Is that less than the degree of the divisor? No. So the algorithm continues. You play the same game. What's the leading term of the new dividend?
6x squared.
What do you have to multiply your 2x by to get 6x squared?
3x.
So that's what we do. And subtract. Let's actually make those green bit consistent. Six x squared minus 6x squared, 0. Negative 13x minus negative 9, it's the same as 9 minus 13. Negative 2? No, negative 4. And that 5 carries down. That was supposed to be in black ink. Look at that new degree. Is it less than the degree of the divisor?
Yes.
No, it's equal, not less. So the algorithm continues. You have to keep going until your degree is strictly less than that of the divisor. Or they can just cut the power, that's cool too.
Well, it would have been 2, right?
Yeah, let's just pause some things and see if eventually the power comes back. I wonder if they cut the power for the wind blew out the power.
I mean, if the wind go with the power, won't be back for a minute. That's like the exponent. So those two, these are the ones that they
And we're back. And the question is, will that come back eventually? Yes, okay. Maybe one of them back up would be nice. Okay, there we go. That was exciting. It's our new leading term. What do you have to multiply 2x by to get negative 4x?
Or negative 2.
Negative 4x plus 6. Subtract 5 minus 6, negative 1. What is that degree?
0.
Which is definitely less than 1. So we're done.
We're going to be 11.
It's 5 minus 6. Remember, you subtract the terms.
Oh.
The quotient, x squared plus 3x minus 2. And the remainder is negative 1. Dividend, 3x to the 5th minus 7x cubed plus 5x squared plus 6x minus 6. Divisor, x cubed minus x plus 2. Well, the divisor is not of the form x minus a number. So again, polynomial long division. I'm going to actually write it this way. It is not necessary to include that missing term. It just makes it more obvious. Dividend leading term. of the dividend. Well, that's the degree.
3x.
3x to the fifth is the leading term. What is the leading term of your divisor?
X to the x cubed.
What do you have to multiply x cubed by to get 3x to the fifth?
3x squared.
There's 3x to the fifth.
And do you always put the, like, what we multiply by, like, we multiply by 3x squared, or 3x squared, do you always put it, like, lined up right above the square?
You don't have to.
Because I usually I put it, like, at the front.
You don't have to. But it does keep everything lined up and neat. Which typically is how I do it when I first go over it. And then after that, I don't. -7 minus -3. -4. 5 minus 6. The other terms will just drop down. Is that degree less than the degree of the divisor? So you keep going. What's our new leading term? So what do we have to multiply by? -4. They drop out. -x squared plus 2x plus 2. What's our new degree? Well, that's the leading term. What's the degree?
2.
Just 2. Is that less than the degree of the divisor?
Yes.
We're done. There's your quotient, 3x squared minus 4. There's your remainder. -x squared plus 2x plus 2.
You gotta put Q of x, or can you just put Q on R?
Technically, it should be of x because it's polynomial, it's a function. And just as a heads up, if you move on, and you have to take calculus 2, we're going to be revisiting this. So you're going to need to know how to do this. Dividend, 2x cubed plus 5x squared minus 10x plus 9, remainder x plus 2. Can we use synthetic?
Yes.
Yes. What is the constant? So what's k?
Plus 2. Minus 2?
It'd be -2.
Yeah. But you have to do something, right?
Because it has to be in the form x minus k. So I can rewrite x plus 2,
X minus 1. That's what I'm
x minus -2. So your constant is -2. So here is how synthetic works. Your K goes on the outside. Now you just list out the coefficients. And the coefficients have to be listed out in the descending order of powers. So the leading coefficient is 2, then you have 5, negative 10, and 9. Leading coefficient just drops down. Multiply that by negative 2. Now add negative 4 and 5. Let's keep those in there. Multiply by negative 2. Add multiply by negative 2 and add. Your quotient has a degree of 1 less than the dividend. So the degree is 2. And those are your coefficients.
How do you get the 25?
Negative 12 times negative 2. And then that last number, which is why I boxed it, is your remainder. Since your divisor is linear, your remainder has to be a constant. Has to be degree 0. And that's synthetic. Are we able to use synthetic?
Yeah.
What is the constant?
4.
Now list out in ascending order of power, or descending order of powers, the coefficients. So what are your coefficients?
-3, 10, 15, 18, 6.
Like that?
Yeah.
Look at what happens between the 10 and the 15.
And 0 in between. So we're going to put 0 in between the 10 and the 15, and then 15, 18, negative 6.
You can't just blindly write down the coefficients. You actually have to look, and that is probably the number one mistake when using synthetic. Also, I could be evil and not give you the polynomial in its standard form. And so not in descending order of powers. And that could also trip you up because you have to then write it in descending order.
Like 15x squared plus 3.
Yeah, so I can put all the negatives out behind. Right, so I'd have all those positives. I could write as 10x to the 4th plus 15x squared plus 18x minus 6 and then minus 3x to the 5th. You'd have to realize that you have to put that negative 3x to the 5th down in front. And then list out your coefficients. Negative 3 times 4 plus 10 times 4 plus 0 times 4 plus 15
17. Negative 17.
negative 17. Oh, this one's going to be fun. Times 4
Negative 68.
plus 18
Negative 50.
times 4
Negative 200.
plus negative 6
Negative 206.
What's the degree of the quotient?
Negative x to the 4th. You're going to start off with negative 3x to the 4th.
So the degree is what?
4.
And then those are all of your coefficients. With a remainder of negative 206. Can we use synthetic?
Yeah.
What is K?
0.5 maybe? Can we use 0.5?
You shouldn't.
Like, wouldn't it be easier to, I mean, like, I guess the calculators could do that, but like,
Problem is, if it's 1/3, what's the decimal of 1/3?
0.33.
It's 0.3 repeating.
Yeah.
So if you use 0.33, you're not going to be right. So it's better just to keep it as a fraction. List out the coefficients.
2, -5, 6, and -3.
Two times a half plus -5
-4,
times a half
2,
plus 6
4,
times a half
2,
plus -3. What is the degree of the quotient?
2.
Quotient 2x squared minus 4x plus 4. Remainder is -1.
What is the degree for that?
Degree is the largest power.
Exponent.
What's the largest power that appears? That's your degree. And so if you look at f of x, what is the largest power you see?
Q.
That's your degree, 3. That's what degree means.
How do you find the degree for the quotient? Or there is
Got Q of x?
a
For synthetic, the degree always decreases by 1. So the quotient will always be 1, the degree of the dividend minus 1, if you're dividing by a linear term. And generally speaking, the degree is always going to be the degree of the dividend minus degree of the divisor. Can we use synthetic? What is K?
-2/3.
What was it?
-2/3. Okay. Oh, it's 2/3.
Positive 2/3. And list out your coefficients.
3, 8, -1, +7, and 2.
Three comes down. What's 2/3 times 3?
2.
Plus 8
8, 10.
times 2/3.
10/3. I'm wrong.
10 times 2/3. 20/3. Plus -1.
23/3.
You did +1.
-1.
Should be plus -1.
-1/3.
17/3.
Times 2/3.
34/9.
Plus 7.
So plus -7 or
No, this one's plus 7.
97/9.
Times 2/3.
194/27.
Plus 2.
248/27.
Challenge yourself and try to do that in your head next time. What is the degree of our quotient?
3.
Quotient 3x cubed plus 10x squared plus 17/3 x plus 97/9. Remainder 248/27. And as a rule of thumb, keep your fractions improper. Here they want us to simplify. If we go back to the division algorithm, f of x is d of x times q of x plus r of x. Multiply everything through by a 1 over d of x. We then have f of x over d of x equals q of x plus r of x over d of x. Which, if you remember your long division from elementary school, right, from primary school, right, you'd sometimes write your answer, your division answer, as the quotient plus remainder over divisor. So that's what we're doing here. Again, it's this form that you're going to need to use in Calc 2. So if we're asked to just simplify a quotient, this is what they want. Again, versus what we were doing before, just finding the quotient and remainder. What's the divisor?
X plus 4.
Can we use synthetic?
Yes.
What is K?
-4.
Now list out your coefficients.
1, -2, -24, 15, 15.
One carries down, times -4,
-4,
plus -2,
-6,
times -4,
plus 24,
plus -24,
0,
times -4,
0,
plus 15,
15,
times -4,
-60,
plus 50,
-10.
So we can rewrite f of x. What is the degree going to be of the quotient?
3.
X cubed minus 6x squared plus 0x plus 15, then minus 10 over x plus 4.
I never understood how like write it in that form, like the R of X, that's the -10 at the end.
Yes. The remainder is what are you left with
Remainder
over the divisor. This is what we would call proper form. Right? Or if you will, the equivalent is a mixed number. What is our divisor?
X was 3.
Can we use synthetic?
Yes.
What is K?
-3.
And actually, let me fix that typo. List out your coefficients for the dividend.
2, 0, -17, -4, and 0 again, and -4.
Two carries down, times -3
-6,
plus 0
-6,
times -3
it's 18,
plus -17 times -3 times 0, or not times 0, plus 0 times -3 plus -4.
5.
Degree of the quotient is what?
3.
So x cubed minus 6x squared plus x minus 3, and then the remainder, that's 5, and then over the divisor. What is our divisor?
1/2. Or x minus 1/2.
Can we use synthetic?
Yes.
What is k? Coefficients of your dividend.
4, -10, 1.
4 carries down, times a half,
2.
plus -10,
-8.
times a half,
-4.
plus 1,
-3.
times a half,
1. 1 and 1/2.
what is it?
1/2. And 1 and 1/2. Oh, -3 and over 2.
-3/2 or -1.5, but keep it in proper. Add -1,
-5 over 2.
degree of the quotient is what?
2.
Right, so f of x simplifies 4x squared minus 8x minus 3 minus 5/2 over x minus a half. Yeah, we don't like that though.
Oh, you can cancel them out and make it 5 over.
We don't like compound fractions. You declare a compound fraction by multiplying numerator and denominator by the LCD. In this case, 2. Depending on your polynomials, this process can be extremely tedious. For instance, if you have like a 15th degree polynomial divided by a linear term, it's going to be really tedious, but not particularly difficult. You just have to remember your arithmetic. Any questions so far?
do have one question. I was checking the last sample, not the last, it's 2s4 minus 17, it's 2 minus 4. When we were doing,
This one?
Why do we put zeros? It's because there is no.
Yeah, so look at the x cubed. What's your coefficient?
Yeah.
It'd be 0, right? 0 times x cubed is 0. So that's why. And same thing with the x, right? What's the coefficient of your x term? Since it's not written, your coefficient is 0. That's why you have to write them. Do this real quick.
And everything will be on the exam up to the like synthetic and bond division.
Also what we do on Wednesday. And let's do one more. And then there's one other handout as well. And there's also 2 there for the next deal. So your exam is next week. It will cover everything we've done up through and including Wednesday, which is finding zeros of polynomials, which is the hardest thing we do all semester, in my opinion. Is it actually difficult? Not really. It's just extremely tedious and long. So that sheet that was just handed out, you can write anything you want on it, double-sided. It does have to be handwritten, though.
And use it on the test.
You're allowed to use it on the exam. And it will be turned in with the exam. So you can bring this with you to the exam, and you'll turn it in with the exam. Whatever you want to put on it. I'm not limiting you to just formulas and stuff. You can also write out examples if you want. Again, the only restriction is it does have to be handwritten. Right, but that's the only sheet you're allowed to use. You do have a couple homeworks coming up as well, right? Homework 6 on polynomials, and then this stuff, dividing polynomials. Don't forget your responses for the second discussion will be due tonight. And your second project is up there. This project is, oh yeah, it has to do with cannonball, right?
Do we have to do groups?
The project is also in groups. Groups have been assigned.
Or is it different?
Yeah, it's going to be different groups. Unless you got lucky enough where the RNG put you in the exact same group. Possible, but low likelihood. Right, so you'll find the groups the same way as before. Should be listed on the assignment. I would recommend that you take this 40 minutes to either start your reference sheet, start the project, or do the homework. And take advantage of this extra 40 minutes. Wednesday we will look at finding the zeros of polynomials. Like I said, it's going to be long and tedious, the process, but it's not particularly difficult. I will see you then on Wednesday.